Hello, everyone, and welcome to Module 6. So, we are nearing the end. We're almost done, which is a little bit insane. I can't believe we're already there. But this week, we're heading into model deployment and monitoring. Whoops, there we go. So last week we covered k-means algorithm. So we were headed into unsupervised learning and we really honed in on k-means and what it means to cluster data. So choosing the optimal number of clusters, that k value, and the applications in customer segmentation and market research. So how do we get to know our customers better? How do we get to understand our market research a little bit? And I do want to point out we focused in on clusters being made up of people, but these can be data points as well. It doesn't just have to be people. And we focused in on clustering, but we also briefly covered PCA, principal component analysis, and we utilized that within clustering so that we could visualize those clusters. Which PCA essentially is taking all of our data points and saying, how can we get those down to just two variables so that we can plot it on an XY axis, get them down to a minimal amount of variables so that we can use it more effectively in modeling, which if you do the not required, the optional reading, it takes away a little bit of the interpretability in a model because you've essentially squished all of your variables into two instead of all of the distinct variables. But it allows to see some interesting things within your variables. It gets down, instead of maybe using thousands of variables, you're now using just a few. This week, we're going to cover model deployment and monitoring. And you'll notice when we go about each of these, we're actually not getting into a ton of detail. And you'll see very quickly why. This is a class where we're not going to get into the highly technical parts of modeling because we no longer have to as data analysts and data scientists. Thankfully, the industry has moved past making one person do all of it. But I did add this module into this course because I do want you to be aware of what's going on. And I want you to basically understand at what point do you deploy a model, what are some of the things you need to look out for when you do deploy a model, and then just basically understanding what do you do with a model after you make it on your computer? Where does it live? Where does it go? And what are some pros and cons of each? So you've built your model, you've gone through, you've figured out this is the one with best accuracy or precision, recall, F1 score. You've gone through all of those, you've figured out this is the best case scenario. But now what? That really depends. Just like a lot of things in data analytics, it completely depends on what you're doing with it. You really need to go back to the original intent behind your analysis. What were you trying to do in the first case? Were you trying to make predictions? Were you trying to understand relationships, forecast, create monitoring systems? So, for example, in homework, I believe 3, you were looking at the Titanic data set. New data is not going to come about for the Titanic. We're not going to predict new data and figure out if this person is going to live or die. So this is not a type of model that needs to be deployed. This one specifically is for, can we figure out the best possible model to figure out what happened in the past? For homework number 2, you were figuring out wine and understanding the relationships and the variables. What is good wine? What influences that quality variable? And how can we figure out the best possible wine without spending a lot of money? So, how can we find the best dupe for it, basically? But some models we would want to put into production, which is essentially putting it live so that a business could use it on new data coming in. So, for example, a churn model is a great example of this. Which customers are most likely to leave our company? We would want to put this in production, deploy it, so that we can use that data and do something about it. We would predict on data coming in, so our customers, either new customers, or we would update our existing customers, and we would figure out, are they going to leave us or are they going to stay? If we think they're going to leave us, we're then going to have some sort of action. We're going to flag them. We're going to put them in a specific marketing campaign. We're going to have a little thing on their profile. So if that they call in, we're going to give them a coupon or they're going to get this special, some sort of treatment. Maybe we have a fraud detection. We would want that in production because if it lives on your computer as the data analyst, the data scientist, it's not doing the business any good if you go back later and then run all the data through. The fraud has already happened and you can't catch it very quickly. If it's in production, though, think about when you run a credit card transaction, it immediately says, this has been flagged for fraud, text this number or call this number to confirm it's you. That's some sort of model that is in production. It scored it as potentially fraud, and you're having to confirm to say, actually, nope, that was a, I always have to think about it, that was a false positive. That's not true. It's actually me. So it depends on what you're trying to do with the model. Not every model is going to be deployed. And actually, I meant to grab the book, but there's a kind of new book by Eric Siegel. He wrote a really great book on predictive analytics. I'll put both of these in our module so you can get the names of them. And he came up with a new book, I believe in 2023, about I will not remember the name of it right this moment, but it's on AI and it's specifically talking about AI deployments. And he calls out that a lot of models are not deployed. And I've been thinking about how to describe this. And the best way I can think of is if you ask any random data analyst, data scientist, have you worked on an analytics project? Hopefully, all of them are going to say yes. If you ask them, have you worked on a predictive model? You're going to lose some of those people because some analysts work mostly on data visualization. They work on SQL. They work on other things other than predictive modeling. If you ask all of the people that have built a predictive model, have you deployed a predictive model? You're suddenly going to get down to a small proportion of people. And that's for many types of reasons we're going to get into this week. The cost, the computational cost, the research and development, the business isn't ready for it. The technical skills aren't there. The technology in general isn't there. The model wasn't built to be deployed. Maybe the deployment process took so long the person actually left before it was deployed. That's happened to me before. So actually deploying a model, it's not as common as you would think. So that's why in this week we're really going over the basics of model deployment so you understand the key things that you need to know, but we're not going to get into specifics. You'll actually see, you might be a little bit happy about this, there's no Python exercise this week. We're actually done with all the Python exercises. I put them all at the beginning so that you get more practice for your final. At this point, we're talking about what comes next, because at this point you've built all the models, you've done all the work. So let's talk about what's next. So deployment is required when your model is intended to make predictions on new data and on a regular basis. I wanted to point out the regular basis part because if it's only once per year, you might not need to deploy the model. So I know some of you work in academia, for example, you're predicting if people will come to UIndy or they won't. That might not necessarily need to be deployed because the cost to deploy it, both in time, technology, and just in general cost, might be greater than the cost it would be just to leave it on someone's computer. So it allows the model to be hosted in an environment closer to the data. So physically closer and on the business's server. So it won't be on your computer anymore. That means that you don't have to be as involved. You're not the one pushing the button physically to make it go. It can run either on its own or it can run maybe overnight or in real time. This reduces the risk of what if your computer breaks? It's just no more. You get the blue screen of death. Your model is still safe. It is somewhere out there and it is okay. When the model is close to your data, so it's no longer having to go from your computer to query a database and back and forth, if it actually lives on your company server, that cost, the time latency, that's reduced quite a bit. So it's much more efficient. And then it enables predictions at an appropriate level. I've seen this time and time again that businesses really want predictions and nearly everything in real time, but very rarely do you actually need things in real time. That fraud detection piece I mentioned, that's something that you probably need in real time. We want to know right away if a transaction is potentially fraud. But if we want to know if a customer is likely to churn or stay, that doesn't need to be real time. That might be something that we run overnight or once a week or even once a month. And by taking that in a more of a batch operation rather than in real time, we can save a lot of computing effort and money. And if something goes wrong, it's not going to clog up all of our systems. However, and I put this in bold and red because I really want to emphasize this introduces complexity that go beyond the field of data analytics. So it goes way more into data science and even more specifically into data engineering, ML ops, way beyond what we're going to do in this class. So I want you to be aware of it, but we're not going to do this in this course because it is highly, highly technical and it is specific to your company, your industry, and the situation. So there's no way I could possibly cover all of it, but I do want to walk you through some examples. And thankfully, we are at the point that this field has changed drastically over the past 10 years. So, about 10 years ago, and even obviously before, businesses wanted these unicorns. They would go out and say, I want someone that can take in data, understand the business problem. They're going to do statistics and visualizations and the baseline analytics. But then they're also going to do the predictive analytics. They're going to build machine learning models. And also, I want them to deploy those models and understand the technology and the engineering and put them into production and make sure it runs really fast and really well and efficiently and break nothing and be on call if anything does break. That, my friends, is a unicorn because it does not exist in real life. I've met maybe one of these people ever. So if you look at the big businesses like the big four, they could find some of these people. Realistically, maybe like in Indiana, no, that's not going to happen. And it's not going to happen at a cost that the businesses could afford. So thankfully, our field has evolved greatly. And even in just the past few years, we have really started to understand and mature and realize that people can't do every single job. Thankfully, because I have no interest in engineering. Some of you may have realized throughout this course that you really like programming, or maybe you really hate it. You'll see throughout other classes that you find specific pieces that you really like and understand. And that's the beauty of analytics. There's something for everyone. Excuse me. So, for example, and I've put into some focus areas, there are others: data analytics, business intelligence, some data science. It's the analytics piece, data visualization, and data-driven decision making. It's focused on there's a problem in the business. We have some data that I think might be able to solve it. Let's do some basic analysis, data visualization, and see what we can do. We start to move into data science, machine learning, and statistics. Those are the people doing most of the mathematical modeling of data, hypothesis testing. And I call it AI models to kind of emphasize that it's the more complex machine learning. That's not to say that these data analytics people are not doing machine learning, but these are the ones moving into the more complex models. They're the ones that are going into very specific details on these models. And then finally, we have these wonderful people in machine learning operations, ML ops, and data engineering that are dealing with the data pipelines and processes. They don't need to understand the hypothesis testing and analytics piece. It's nice if they do, but we need them to understand how data moves about on all these servers. We need them to understand the ETL process: extract, transform, load. We need them to understand how do we get this model up and running without breaking the entire system. And we want to be able to work with all of these people cohesively so that we can produce a product that actually is worth something. So thankfully, we have taken all of these areas, which used to be on one single person or one single department, and we've split it across pretty well. Again, thankfully, because we are no longer looking for the unicorns. We are looking for real life people that can actually handle these tasks. So I do want to share an example, though, from my time at Fan360. I was a data scientist there, so I was working on predictive models. I was still doing the analytical work, but thankfully, a lot of the deployment part, I was working with a data engineer that would help. And part of this is I wanted to share the technologies that were used in case you're interested and want to look some of these up. So the model was built in Python using a Jupyter notebook, just like you've been working in this entire semester. Now, we did translate it to a different type of Python workflow just to make it run a little bit faster, but it was 100% built using a Jupyter notebook. Using Apache Airflow, so that's that symbol right there, that's a scheduling system. I scheduled a job, so a task, to run every single night because we didn't need real time, we just wanted it to run every night. It ran a SQL query, which you will get into next 8 weeks, using PostgreSQL, just a type of SQL, a flavor of SQL, if you will, to obtain the necessary data for the model. It scored the fans using the model and the Python code. So you know how you need specific types of data for your model. The SQL would go out, get that data, put it into the model that was already built. It would score each fan, and then I needed to save the output back into the database. So go get the data I need, put it through the model that was already built, and then save it back to the database. So I've got the model, I just want the results saved back. And then I note here along the way, I had help from 2 other talented data scientists and a data engineer. And this was the most simple model I've ever built. It was very, very simple, but it was something to get us started so that we could better understand how engaged fans are at any given time. So this was taking data, running it through a model in Python, and then just using a few tools with the help of a data engineer and other data scientists to support me. So you are not alone when you're working on these types of things, thankfully. If you are starting out in a business, you are going to be, hopefully, you're going to be with a team that's going to help you out on the deployment part because it is a lot of technology, it's a lot of moving pieces. And you're typically working with technology that you're not expected to understand every facet of. When a model does get deployed, there are a few things you need to understand that might happen because when models are deployed, they should perform the same or better than they did at testing. Now, that's not always going to happen. Sometimes you get in new data and the model does worse. So just be aware that that might happen. But the model is always going to have some slight variations. So, how do you know when the model needs to be retrained or it needs to be paused so you can kind of take a second look and see what's going on? The first thing you need to look out for is model drift. So, you're still going to use accuracy, precision, the same evaluation metrics that you used before. You're going to figure out the ground truth. So, what are you testing against? Just like you did in the training part, you tested against the truth. You need to still be able to do that testing in production. You're going to, again, do the same types of testing, accuracy, precision, all of those same things. And you're going to track those over time. So you can see, is the model getting better over time, worse? And again, it's going to fluctuate. Some days, some weeks are going to be better than others. But if you notice the model is slowly getting worse over time, you need to consider retraining your model. There's also this thing called data drift. So it's not just that the model is drifting, but the inherent data in the model is starting to shift. And this makes sense if you think about it, because if you put data in a model, human behavior changes over time, data changes over time. Maybe we need new variables in here. Maybe we need to train the model because suddenly variables are interacting in a different way. So as data is ever changing, so are the relationships between variables. So again, slight variations are normal, but consistent shifts in performance will require retraining. These go hand in hand, and sometimes you don't know if it's the model that's drifting or if it's specifically the data has changed, that there's some sort of relationship that's changed. And really it's both. If the model has drifted, the data has likely drifted. But you won't know until you retrain if it's that the inherent relationship within the data has changed, or if now you're missing a variable. The relationship has changed so much that now you need to include a new variable. But I do want to go over one interesting example where the model drifted, but only for a short period of time. So I started working for A Place for Mom in 2020. And this is a company that helps place the elderly into nursing homes, senior living facilities. And the person that had my job before me built the model in 2018, and he left in 2020. So I get hired in 2020. I come in to take over his model. And the model, obviously, because of COVID, it starts degrading. The performance starts actually getting pretty poor. So I come to this decision point. Do I retrain a model that I have never used? I was not involved in building it. I just started at this new job. It's been in production for 2 years. Or do I take a second and just let it do its thing and see what happens? I took a gamble and I let it go for a little bit because I looked at the variables that were involved. I looked at what was going on with COVID and I said, I knew senior living was in a really interesting place. And if I retrained the model at this point, it would learn from COVID data. I did not want the model to learn from COVID data until I knew that COVID data was permanent. Thankfully, it wasn't. So I left the model as is. I let it run in a way that I knew was incorrect. And I let them know that, hey, the model was going to be a little off for a little bit, but just keep on doing the best you can. Thankfully, the model was not in a place where it was real time or anything. It was just giving hints at these are the people most likely to be a good sale. So you also have to weigh the pros and cons. This was not a model that was going to ruin anyone's life. It's just giving hints at this might be a good sale. So I left the model as is. And thankfully, around the time the vaccine started coming out, the model slowly started getting back to peak performance. Once sales returned to normal, people started returning to normal, the model also returned to normal. It didn't need to be retrained until, thankfully, after I left, they just started the conversation about retraining it because it had been at peak performance and human habits just returned back to normal when it came to senior living. So that's an example of sometimes we think something is happening in a model, but we also have to consider outside factors. Maybe there's a global pandemic that is influencing our model. And when we retrain a model, we have to understand that new data is going to heavily influence the model. Do we want it to, or maybe we should take a second and think about what's next? So as I wrap up this module, again, we're not doing any Python exercises because deploying this module model thing is getting me. As we deploy a model, it is going to heavily depend on what industry you're in, what company you're at. The technical component is heavy. I only posted one other video this week because as you notice, there's a lot of technical pieces in there, but that's why we have our friends in ML ops and data engineering. You're going to work collaboratively with a lot of people there. So it's important that you know your piece. What is the business problem? What do you need to know about your model? What are you trying to do? Are you predicting? At what time periods do you need to predict? Can you do batch? Does it need to be real time? And what are some pros and cons to that? If you're predicting in real time, there might be some issues with some technology. It might add up in costs. And think about the technology piece of if something has to be real time right now, that's going to cost a lot in server space and just keeping things up and running. And consider that trade-off between latency and computation cost. If you can batch predictions, that's going to save you a lot of computation cost. Understanding model and data drift, where sometimes your model starts to get off a little bit because the inherent relationships between data has shifted, or maybe data itself has changed and you're now missing out on some variables that are important, or variables that were in your model are now no longer important. And then deployment technologies and complexities, just understanding that not everything is push a button and it's live. It's actually very complex to put out a model, deploy it, and monitor it. And that's why actually not very many data scientists have ever deployed a model. It's actually not very common. And I will post the Eric Siegel books just so you're aware of them if you ever want to read them. I'm just starting to read the AI book if you'd like to follow along as well. With that, have a great week, and I will see you next time. You'll notice your homework for this week is a reflection of this course. I want to know how you feel about your Python skills, your predictive analytics skills. Point out the things that were really hard. Some of you really struggled with homework, and that's okay. Tell me about it. What are you looking forward to next? And then what can I improve about the class? So I do want you to fill out the survey for the course, but also just tell me what can I do to make it more fulfilling for the next cohort of students. All right. Thank you all.